All right, so the next thing we're moving on to is solving trigonometric equation. So for this, you may or may not need a calculator. Well, so keep it, ensure you have a calculator sort of near. Example 21 says, solve the equation. We have what? 2 cos squared 2 cos squared x minus 3 sine x minus 3 is equal to 0. And they're asking you for answers, because remember, whenever you solve a trigonometric equation, there's an infinite number of answers, but they're asking for answers only between 0 and 360 degrees. All right, what I notice here is that this is for me, this is a quadratic equation, because the highest power of the unknown is square. I also notice that I can get the entire equation in terms of one trig ratio only, and that is the sine ratio. I can get the entire equation in terms of the sine ratio, because cos squared x is another way of saying cos squared x is to say 1 minus sine squared x. And of course, that is coming from the identity that sine squared x plus cos squared x is equal to 1. So cos squared x is equal to 1 minus sine squared x. So I just simply replace cos squared x with 1 minus sine squared x minus 3 sine x minus 3 is equal to 0. Removing the bracket by applying distributive law, 2 times 1 is 2. 2 times sine squared x is 2 sine squared x minus 3 sine x minus 3 is equal to 0. Then simplifying, minus 2 sine squared x minus 3 sine x minus 1, because 2 minus 3 is minus 1 is equal to 0. All right, sometimes I don't like to work with so much negatives, so I'm going to multiply the entire equation by minus 1. If I do that, I'm going to end up with 2 sine squared x plus 3 sine x plus 1 is equal to 0. So now what I have is a quadratic equation with only one unknown, and the unknown here is sine x. So using the method of factorization, I'm going to have, I didn't even check. I'm assuming it can be factorized. 2 sine x here, sine x here. Of course, it's only 1 and 1, plus and plus is equal to 0. So what all I did here was just to factorize the quadratic expression. And now we have, I'm multiplying two things and I'm getting 0. So it's either the first that is equal to 0 or the second that is equal to 0. So here, sine x is equal to minus a half, or sine x is equal to minus 1. Now, sine is negative in the third quadrant and in the fourth quadrant. Sine is negative in the third quadrant and in the fourth quadrant. So I'm looking for answers. So my answers are going to be between 180 and 270, and between 270, and 360 because sine is negative in the third and in the fourth quadrant. So starting with, I'm going to have over here, x is equal to sine inverse minus a half. And over here, x is equal to sine inverse minus 1. My answers, x would be equal to sine inverse of a half is 30 degrees. Sine inverse a half is 30 degrees. Now, since my first answer is in the third quadrant, the first answer is going to be 180 plus 30 degrees. And my next answer is in the fourth quadrant. So that is going to be 360 minus 30 degrees. So my answers here are 210 degrees and 330 degrees. Over here, sine inverse, the sine of 1 is 90 degrees. The sine of 1 is 90 degrees. So sine inverse minus 1 is 270 degrees. Or you could say 180 plus 90, which is 270 degrees. So my solutions are x is equal to 210, 270, and 330 degrees. Those are my solution to this trigonometric equation. All right, let's have a go at example 22. Now, example 22 is asking us to solve the quadratic equation 3 minus 3 cos theta is equal to 2 sine squared theta. All right, and of course, they're asking for answers for theta or for values of theta between 0 and 360 degrees inclusive. All right, so what I would do is I would do this. It's a quadratic equation. So I'm going to have 3 minus 3 cos theta minus 2 sine squared theta is equal to 0. Now, of course, trying to solve this, it's going to be difficult trying to solve this if I have two different variables or two different unknowns. So right now my unknowns are cos theta and sine theta. If I can arrange my equation so that I can have only one unknown, it would be easier to solve. And I can do that because sine squared theta, sine squared theta plus cos squared theta is equal to 1. So sine squared theta is 1 minus cos squared theta. So I can arrange my equation in terms of cos theta only by changing sine squared theta to 1 minus cos squared theta. So now I have 3 minus 3 cos theta minus 2 into 1 minus cos squared theta is equal to 0. Next, I'm going to remove the brackets by applying distributive law. 3 cos theta minus 2 times 1 is 2. A negative times a negative is a positive. 2 times cos squared theta is 2 cos squared theta is equal to 0. Simplifying, I get 2 cos squared theta minus 3 cos theta, this is theta. 3 minus 2 is positive, 1 is equal to 0. So to solve this now, I'm either going to, it's a quadratic equation. I'm going to factorize if it can be factorized. And if it cannot be factorized, then I am going to use the quadratic formula. So let's check if it can be factorized. I think it can be. 2 cos theta cos theta, 1 and 1. I think both of these need to be negative, is equal to 0. So if you're multiplying two things and you're getting 0, it is either the first 2 cos theta minus 1 is equal to 0, or the second cos theta minus 1 is equal to 0. So cos theta is equal to a half, or cos theta is equal to 1. Now, if cos theta is equal to a half, it means that theta would be equal to cos inverse a half. And over here, theta is equal to cos inverse of 1. Now, cos is positive in the first quadrant and in the fourth quadrant. Cos is positive in the first quadrant and in the fourth quadrant. And the the cos of 60 degrees is a half. So cos inverse a half will give you 60 degrees. So theta is 60 degrees. That is my answer in the first quadrant. And my answer in the fourth quadrant is going to be 360 degrees minus 60 degrees. Over here, the cosine of 0 is 1. So cos inverse of 1 is 0. And the cos inverse of 1 is also 360 degrees. So my answers are theta is equal to 0, 60, 300, and 360 degrees. All right, so example 23 is asking us to solve the quadratic equation, the trigonometric quadratic equation, 2 sine squared theta plus 1 is equal to 3 sine theta. So it's a quadratic equation. We need to make one side of the equation equal to 0. So now we have what a quadratic equation in one unknown, the unknown being sine theta. So let's find out what sine theta is. Using the method of factorization, it's minus 1 is equal to 0. So therefore it's 2 sine theta minus 1, that is equal to 0. or sine theta minus 1 L is equal to 0. So sine theta is equal to a half, or sine theta is equal to 1. Working with the left-hand side first, theta is equal to sine inverse a half. Now, since the examiner did not give me a range for my answers, I'm going to write my answer as the general solution for sine. So the sine of 30 degrees is a half. So sine inverse a half is 30 degrees. So my solution is theta is equal to, I think it's what, n pi plus minus 1 raised to the power n. 30 degrees would be pi by 6. Or I could write it in terms of degrees. Right now I'm writing it in terms of radians. In degrees, it would be 180 degrees. N plus minus 1 to the n, 30 degrees. Over to the right, theta. Now, the sine inverse of 1 is 90 degrees. So theta would be, sorry, let's put sine inverse 1. So theta would be n pi plus minus 1 to the power n, pi by 2, which is 90 degrees. Or in degrees, it's 180 n plus minus 1 to the power n, 90 degrees. So that would be my answer or my solution to this trigonometric equation.